Conditional probability example. So in a certain selection of flower seeds, 2/3 have been treated to improve germination, 1/3 have been left untreated. The seeds which have been treated have a probability of germination of 0.8, whereas the untreated seeds have a probability of germination of 0.5. So in part 1, they want to know what is the probability that a seed selected at random will germinate. And for that, I am going to use a tree diagram to kind of help set things up. So first thing we have is that 2/3 are treated, 1/3 not treated. So I'm just going to use treated and not treated. And that would be 2/3 here, 1/3 here. And then they tell me some information based on whether or not it was treated or untreated. So the seeds that have been treated would germinate with a probability of 0.8. So coming off of the treated branch, we have germination 0.8, and not germinating would then be 0.2. For the untreated, we have a germination of 0.5, which means that the not germinating is 0.5 as well. So we want to know the probability of germination, so I really need to follow these branches down to the germination ends, and we can either have this result from multiplying 2/3 times 0.8, or the other result, 1/3 times 0.5. So your probability of germination is going to be 2/3, and I'll just write this out first in probability notation. We're going to have the probability that it was treated times the probability of germinating given that it was treated, and then we're going to add that to the probability of not being treated times the probability of germinating given that it wasn't treated. And then we'll start getting these pieces of actual numbers in there. So we'll have the 2/3 for treated times 0.8 plus 1/3 times 0.5. And the first fraction multiplied by 0.8 would give you 1.6 over 3. And then you would have 0.5 over 3. And this will give you 2.1 over 3, which when you divide that out, you get 0.7. So probability of germinating is 0.7. And then for the second one, they want to know the probability a seed selected at random had been treated given that it had germinated. So what we're looking for is the probability of treated given germinated. And if you look up at what we did in part 1, we just have germinated given treated based on our tree diagram, based on the information that was given. So this is another place where Bayes' formula will come into play. And Bayes' formula, or Bayes' theorem as it's often called, but I'll just call it the formula for now. The Bayes' formula says that if you have the probability of A given B, that's going to be the probability of B given A times the probability of A divided by the probability of B. So here in this scenario, that means that we would have the probability of germinated given treated times the probability of treated divided by the probability of germinated. And thankfully, all this information is available to us. So germinated given treated was 0.8. The probability of being treated was 2/3. And the probability of germination, we found that in part A, that's 0.7. And when you work all that out and just put that in the calculator, I am getting 0.762 after rounding and out to 3 decimal places. Okay, so another situation here, you have the tree diagram that helps. Very useful to organize the information. And then Bayes' formula, very useful formula in the conditional probability world. And I hope that helps, and thank you for watching.